Gostaria de convidar a Jo Gailani, do Corpo Engenheiro Estados Unidos, para apresentar o papel do ERDC, né, para o desenvolvimento sustentável.
Thank you. And I'm going to talk about the ERDC, the Engineering Research and Development Center of the Army Corps of Engineers, and specifically our Coastal and Hydraulics Lab, and specifically our Coastal and Hydraulics Laboratory in Sustainable Development. The U.S. Army Engineer Research and Development Center services about 30 districts that are divided across the country. There are divisions which are shaded in yellow and shaded in different colors, and within each of those is these dark black boundaries, which are the different divisions, or excuse me, different districts. And each district has its own management culture and style, and we're there to service all of them, as well as other government agencies, private entities, and international cooperation. So, something we do for a port in one district may not get translated to another district unless we tell them, hey, we did this at the Port of Savannah, this should work at the Port of Mobile. They might have no idea that we were doing research there. The Engineering Research and Development Center is 2,500 employees divided among 7 laboratories. The Cold Regions Research Engineering Laboratory, probably not relevant to Brazil, a lot of ice work there. Geospatial Research Laboratory, Construction Engineering Research Laboratory, and then the headquarters are in Vicksburg, Mississippi, and there are 4 laboratories there. The Coastal and Hydraulics Laboratory, which I'm out of, our sister laboratory, the Environmental Laboratory, then the Geotechnical and Structures Laboratory, and the Information Technology Laboratory. And some of the business areas that ERDC works in are military engineering, and military engineering is actually very interesting because the sustainability that ERDC does really started there, that our installations were getting degraded quickly and something needed to be done. So before we took this sustainability to our civil works mission, our ports and harbors, waterways, coasts, it was being worked on in our military engineering branch. Environmental quality and installations, civil works and water resources, which is where all of our navigation work and ports and harbors and waterways work falls under, and then the geospatial research and engineering. And that's rather interesting that we have an entire branch dedicated to geospatial research, and that really helps us manage data better over a broad country and interconnect databases and such. And the reason I put this slide up, this slide is not my slide, this slide is that one that comes from the generalized ERDC briefing, is because words come up in here like sustainable, risk management, system-wide resources management, and stewardship that are all relevant to sustainability. And I did not edit this slide to get that. It just naturally comes out of our work that sustainability is a critical factor because it reduces our costs, it reduces the amount of regulation that we're fighting with regulatory agencies and our partners in the endeavors that we perform for the nation. And the ERDC role. Basically, ERDC performs research and development relative to the Army Corps' mission and implements this R&D into practice. For civil works, our main clients are these districts within the United States. We do direct research for them, the way a consulting firm would do. We develop new tools, databases, and models, which we just then hand over to their engineering and scientific staff. And we also provide technical support. Short term, they want someone to come down and talk about a specific topic, we'll bring that person down. The sustainable development in waterways and civil works really has to be initiated by each district. We build the tools to help them do that. They come to us for that work. They could just as well go to a consulting firm or to Deltaris, for example, and they do sometimes. But we are there as a in-house resource for them. And we're there to develop the capabilities that the district will need to apply through our research programs. We have some world-class research and development facilities. We have a supercomputer center. It's one of 5 within the Department of Defense. A lot of that is dedicated to civil works. We have large hydraulic models. This just shows you a variety of the work we do: environmental research, ice engineering, hazardous and toxic waste center, large-scale blast simulation. Not that that's of interest really here. And now getting to the Coastal and Hydraulics Laboratory within ERDC a little bit. We're located on the Mississippi River, which means we're away from the coast, which means we maintain a facility at the coast in North Carolina, in Duck, North Carolina. And a lot of our field work is based out of that field research facility. So even though we are a Coastal and Hydraulics Laboratory located inland, we do have a coastal facility where a lot of work goes on, including long-term monitoring to see how things evolve on the decadal scale. And then at our facility in Vicksburg, we have large-scale sediment transport facilities for nearshore environments, estuary and experimental flumes for large-scale experiments similar to what you've seen at the Fleming's Research Institute, Fleming's Hydraulic Research, and erosion and other sediment studies. We work on innovative civil works, including navigation. We have a ship simulator similar to what was presented in the previous presentation. I don't think there's anything I can say about it that wasn't said by the previous speaker much more eloquently. We use the same type of photographs using the circulation models to develop the hydrodynamics, bring the pilots in. They say for the present conditions, yes, this is how ships behave in this waterway during flood tide, for example. And then we modify the system, deepen the channel, change the channel alignment, bring them in, and we have some confidence based on their acknowledgement that the ship behaves this way under current conditions, that it will behave that way under the modified conditions. And we have the flood and coastal storm damage reduction. Really, we've come to realize that it's risk management, not preventing all flooding and damage within the United States. We're trying to manage the risk and reduce the risk as opposed to eliminate it. And that requires a lot of prioritization and an awful lot of politics. We try to keep out of the politics and stick to the science and let the districts handle the politics of the situation. And then regional watershed solutions. This was really where the districts treated each segment. There was a person who was supporting that, say, a segment of the Missouri River or something. They didn't care what happened downstream or upstream or in the watershed. They were there to manage a specific portion of the river. This whole idea of watershed management solutions came out of, for the core applications, the tools for that came out of the ERDC. And then we have the environment, which is a big issue for us. I'll talk about that a little bit as we move on. One of our big issues right now is invasive species and how to handle them. And we're doing a lot of research in this area. We have species which are really overtaking the native species. One of them, for example, is the Asian carp, which is not only eliminating other fish, but causing a danger in that people are having to put on their recreational vessels grates over the windows because these things jump out of the water, hit the windshield and smash it. They've hit people and injured people. They're really getting out of control in some of our waterways. It's really something to see them jumping. This picture here shows them, and it looks like this. It really does. When they're swarming, they look like that. And we're talking about introducing another invasive species that's used, that in Asia controls the Asian carp population. But a lot of studies have to be done before then to see, do they have a preference for Asian carp, or would they start to prefer one of the native species over that? So we do work like that to try and get our waterways back to what they were and we consider that sustainable, a sustainability issue. We're developing new coastal storm modeling systems that work on multi-scales, and they're highly skilled numerical models in an integrated framework with what they call a user-friendly interface. I would differ somewhat with that statement, but this is not my slide originally. And we use this to look at flood risk management and flood risk reduction and sustainable coastlines. One of the big things that we looked at sustainability in was our response to Hurricane Katrina. After the hurricane, we had a lot of damaged levees. We had a certain amount of money to build them back. We realized we couldn't build them back to meet all Category 5 hurricanes, but we learned a lot from the damage to the levees that occurred. We tried to replicate that in the laboratory at scales using things like a centrifuge, which can go up to 300 Gs, to look at how the levees collapsed and how we can modify the levee design to make it more sustainable during the next hurricane. In the coastal and hydraulics branch, we're divided into two major missions: flood risk management, which is the second one, and civil works research. And we have our districts each year get together and apply with what they see as their strategic needs and priorities for research and for tools. And if you look at this list here, I put these up here to show how much of this pertains to sustainability. Things like extending the useful life of existing navigation infrastructure, system-wide integration of waterborne transportation assets, prioritizing channel availability for commercial freight movement, engineering with nature, and develop more sustainable methods to support navigation and flood risk reduction while minimizing impacts on habitat. And a different group came up with the list of strategic needs for flood risk management, and they have a similar sustainability bent to them. The sustainability is a key term here. And just in summary, kind of a definition of what we see the Coastal and Hydraulics Laboratory as, is the only U.S. federal laboratory dedicated solely for coastal and hydraulic research. CHL, as it's called, makes the nation and the world a safer place for developing and using cutting-edge technologies. And just a little bit of a plug here, we do work internationally. We can work through CRADAs, what we call cooperative research and development agreements, with different organizations around the world, and we do that. And it lets us export some of our technologies, models, tools, databases, and know-how to others. And with that,